Hello, this video is for Chapter 8 Tech Project, and we'll be looking at Part 3. So this one uses the application Birthday Simulator located in the StatSims folder, and we're going to be attempting to estimate the chance that at least 10 people out of a group of 32 will be involved in a birthday match. I'm going to change that size to 37, just so that it's a little different from yours, but all the rest should be a good example for you. So we want to open up that sim and enter our name in the text box and put in our group size, which again I'll do 37. So it is the birthday simulator that we're going to use. Put your name here. Change the group size from 40 in your case to 32. I'll do 37. Entering 10,000 for the number of simulations should be fine. That's getting us started. So let's go ahead and see what's next. Suppose that it's reasonable to assume that the true probability of at least 10 matches is less than 1%. Calculate the minimum sample size. Let's highlight that for a second. Calculate the minimum sample size. Sample size is n. So they're asking us to calculate the n that we need to estimate the probability of our question up here with a margin of error less than 1% using 95% confidence interval. Show your work and handwrite the math or equation editor is fine, but it needs to look good. So either handwrite it or type it. And a hint, the answer should be between 60 and 70,000. So the first thing is, what are we trying to do? We're trying to figure out sample size. So we're doing a confidence interval for proportion, and we're trying to figure out sample size. So I have the formula sheet here. For proportion confidence intervals, this is this line. Sample size is n. So here's the formula that we want to use right there. Not highlighting really well, but there it is. So if we want to find n, we need a guess at p, we need a z-score, and an e, and then we can plug all those in. I'm not going to do the work on this, but this is very similar to what we did in the chapter problem for Chapter 8. So if you look at the solution manual for that, that will be helpful, and I'm going to just talk through where we get these three pieces from real quick on the screen, or actually let's see, from the handout, on the tech handout. So when they tell you that they're pretty sure the probability is under 1%, you're going to use that to guess at p. When they tell you they want a margin of error of 0.1%, that's telling you e, but you need to change it to decimal form. And the 99% confidence interval is going to be used to figure out the z. You might want to draw a picture for that and work backwards. So show all that work and put that in your report either by hand or well-typed math. For finding the z-score, if you want to show your work on that, you could use the normal CDF or normal distribution program and the inverse CDF to find your z's if you want, or you can do it by hand or use your calculator, but just show your work on that. And you need to get an answer between 60,000 and 70,000 or something's going wrong. So what I'm going to do is enter a number in that zone into the StatSim. Whoops, pull that back up. So I'm just going to enter 65,000, which, by the way, that's what you should do if you cannot figure out the answer correctly. But to get full credit, you got to figure it out. So I'm going to do that, and then let's see what's next. Click the Simulate 1 button to simulate what's happening here, how many people were involved in a birthday match. So I'm going to click Simulate 1, and what it's saying is there were 4 people involved in a birthday match. So there's two ways that could happen. It could be 4 people out of the 37 all had the same birthday, or it could be 2 people had a matching birthday and 2 other people had a different matching birthday, but 4 people in that group can say they matched somebody else. Let me do it again. There's 2 people that had the same birthday as each other. On the third time, nobody in the group had a matching birthday. So sometimes we get the match, sometimes not. Alright, and then we did that, and click the automatic button to run it out the 65,000 times, or however many times you computed and filled in. Shouldn't take very long for that to happen. Up to 20,000 already, so we'll be there in a moment. Let's see what's next while that runs. Use the summary of all simulations and the total number of simulations to determine the probability of, the proportion of times in the simulation we had at least 10 people involved in birthday matches, and write your answer as a fraction at first and then using 6 decimal places. Alright, so let's go have a look back at that. It should be done by now. So sometimes you'll get matches down below this. I don't think there are. You can expand the window a little to see, but there's nothing else down there. So 10 or below would be from this 833 down to that 3. So I'm going to bring the calculator in and I'm going to add those up. So I want the 10 matches, 833, plus anything that was more matches because it said at least. Okay, so 1, 2, 3, 4, 5, 6, 7 numbers. 1, 2, 3, 4, 5, 6, 7 numbers. So I think I've got that. And it's 1146. And 1146 out of what? It's 1146 out of 65,000. So 1146 divided by 65,000. So 0.017631, because they said to write that out to 6 decimal places. So I'm not going to type that up in the report for time here, but this is a p hat because it's from a simulation. It's a sample proportion. So p hat equals 1146 divided by 65,000, which is approximately equal to 0.01763 and then a 1 for our 6th decimal point. So that will be the p hat that I would use. Yours should be a little bit different because your group size is different and because the number of simulations you did is different. But that's the idea for getting p hat. Let's see what's left on this project. So we just did that part. So is it likely that our sample proportion from G before rounding is exactly equal to the true probability? So what we just calculated in G is a p hat. The actual or true probability is p, and the probability that p hat equals p is always 0. So there's no chance that we have the right answer there. So you'd want to type that up. And the explanation is just that the probability of p hat equaling p is always approximately 0. And then since we don't expect that our point estimate up here from G was exactly correct, we shouldn't stick with a point estimate. We should go to a confidence interval. For the 99% confidence you need a z-score. You should already have that z-score from your work up here. And then you can use the formula for proportions to calculate out that interval. So just a couple quick mentions there. When you're doing proportions, this is your formula right here. So the p hat we got in part G, the z we calculated up at the beginning of the project, and then we use that p hat again here and here. A common mistake is for people to put the size of the group, 32 or 37, right there. But when we did p hat, we did x over n, and I divided by 65,000. You would never use a different n for your p hat than right there. So if this was 65,000 something, then this one should be 2. So whatever number that you had for your number of trials will get calculated in the denominator of the p hat and in the denominator of the square root. So don't fall into the trap of using the 32 right there. And then when you show your work on this and you compute the margin of error, since we put 6 decimal places on p hat, we should also put 6 decimal places on the margin of error. And then remember to write your answer in interval notation with the appropriate symbol. And then interpret that. So kind of a standard interpretation of a confidence interval right there. Okay, hopefully that will help you through some of what are normally the sticky spots for people on this project. Good luck.